Okay, thanks very much, Claire, and good morning, everybody. So I intend to try and keep this talk down to about 45 minutes. Sometimes I've given this talk and ended up talking for several hours, so I'll try and avoid that rather than keeping you all day. And let's try and keep it down within the hour as we're scheduled. So what I want to talk about this morning is various aspects which has been happening over the last few years in terms of the modernization of the satellite navigation systems we have, and also some recent developments in terms of national activities related to PNT. And of course, I'm sure you're all expecting me and waiting to hear eventually we have some announcements of activities within the United Kingdom. So I'll finish off the talk with a brief look at what has been announced by the UK government in terms of the National PNT Office. So if we start with the satellite navigation systems themselves, GNSS, Global Navigation Satellite Systems, of course, we have the four now quite well established global systems. And I'm sure many of you are aware, many of them have been there for quite a number of years. GPS itself is celebrating 50 years this year. And at the very moment, in fact, in terms of the announcement of the program, the establishment in September, and then the final initial funding in December of 1973. Glonass, a similar long period, rather troubled periods, a number of years, 20 so years ago, but also well established now. And of course, more recently, Galileo, the European system, and Beidou. Perhaps we ought to change the title of Galileo, not the word Galileo, but we always say it's a European civil control system, which is still correct. But of course, it's a matter of, are we talking about geographically Europe or politically Europe these days? And then in addition to that, there are regional systems in operation in Japan, the QZSS, NAVIC is the now operational name of India's system, and in development, the Korean KPS system at the moment. And of course, there have been discussions about whether the UK would establish a global or a regional satellite navigation system. And some of you have probably seen that the study report on the space-based positioning system has recently been published now, even though that work was conducted a year or so ago, 2 years ago maybe. And additional then augmentations to the core systems, as what we call space-based augmentation services, primarily driven by aviation requirements and applications and uses. In Europe, EGNOS, which the UK no longer has certified access. In WAS, the WAS system in the United States, MSAS in Japan, GAGAN in India, and the developmental SDCM within Russia. And again, other systems are in development as well. In Korea again, in Australia and New Zealand, the SouthPAN system, which is developing quite rapidly from the initial prototypes to the first deployments of that now. And again, there have been discussions about maybe a regional system could happen within the UK. And indeed, there have been test signals over the last year or so. So if we start with GPS, just a very quick overview. I'm not going to say anything about how the system works, but the current status in terms of the operational spacecraft is a number of different generations of satellites, what we call blocks. The original Block 1s and Block 2As disappeared many years ago. And you can see the current status there. So of the older satellites, the 2Rs, there are 7 of those in operation. In fact, one was brought back into operation recently from its residual status. 7 of the 2RMs, 11 of the 2Fs. There were originally 12 of those, and one of those, oh, sorry, it says block rather than block. I should say block. 11 of those, and one has been retired to residual status because of a problem within the last year. And 6 of the most recent spaces, which are called Block 3. And the first part of that is Block 3A. The first 10 of the satellites are designated as Block 3A. So 6 of those are launched and operational now. And as I've suggested, a number of the other spacecraft are still there as what's called residual status, or indeed test status for one of them, which allows them to be potentially brought back into service if there is a distinct requirement, and maybe one of the operational spacecraft is having a problem, and so one of the reserves, if you like, can be brought back off the bench into the main team. As it says on the next line of the slide there, only one satellite was actually launched in the last year. That was earlier on this year. There's been a bit of a pause in the schedule where those 6 are operational. The next scheduled launch is probably not until the summer next year, so June is the not earlier than date for the next satellite launch. As you can see, though, the GPS is to some extent a victim of its own success, that the spacecraft have been very long-lived and very successful, and we now know the success of the system itself. But that result of that is many of those 2R satellites are well beyond their design lives. And as you can see on the slide there, some of them are between, well, they're all between 19 and 25 years old. And they were designed to less, let's say about 10, you know, that is a sort of a general figure. So it's a very old spacecraft now. That's simply that longevity, which, as I say, is to some extent a little bit of a drawback. It's great in terms of the technical success of the system. It's not so good in terms of modernization of the system when you're trying to get updates, because the updates in terms of the new signals require, as you can see in the next slide there, the policy for many years now has been launch on requirement or expected requirement. If a satellite is coming to the end of its practical life and it needs replacing, then new satellites are scheduled to be launched, not simply to upgrade the capability. And this very success is to some extent inhibiting the modernization of GPS because, as I said, new signals, new services require new satellites. This has been an issue that's been discussed for some years now in terms of perhaps future spacecraft should be more flexible and therefore they can adapt to changing requirements in terms of signal structures, and rather than requiring, if you like, the hardwired approach, which is the current policy within the GPS spacecraft. As it says on the slide there, the 4 remaining Block 3s are waiting on the ground. They're all built and ready and tested, and they'll be launched over the next few years. The earliest next launch potentially is next summer, and then over the next 2 years after that to get those 4 remaining Block 3s. The Block 3F satellites have also been contracted now, so this is the next generation of spacecraft. And again, these will be small evolutions in terms of some of the capabilities the spacecraft will have. From a military point of view, what's called the RMP, some of you may have seen this acronym. This is the new regional military protection, something that's been discussed many years, where the military signals, the M code, the new military signals, would have increased power in focused areas to give more protection against interference and jamming and spoofing. An improved nuclear detection system, one of the other key payloads on the GPS satellites, search and rescue payloads for the first time, and a laser retroreflector, which was tested on some of the spacecraft many years ago, just as an experiment, but now all the spacecraft will carry the retroreflector, which allows ranging, very precise ranging from ground-based laser ranging systems. Something very close to my own heart, because that's why I did my PhD in way back in the early 1980s. So this is a slide some of you have seen many times before. It's been updated many times, but it still gives a nice summary of where we are in terms of GPS modernization. So the far left-hand column, where it says GPS 2A and sort of onwards, are the legacy signals. So what we've used for the last 50 years now in terms of the single frequency. The red ones on here are the civil signals. The ones in black and other information is obviously includes some of the military signals. So the L1CA code is what many of us use. That's what the billions and billions of users around the world are reliant upon. Single frequency using the CA code. And then alongside that, the precise services coming from the encrypted P code into the Y code on the 2 frequencies. So that's what GPS was originally designed to do, and that's what it still does do. And the vast majority of users are still just using those signals. But then modernization started around about 2005 with the first launch of this first 2R or 2RM satellites, including the new L2C signal. And this is where the new military signal came along, called what I mentioned earlier, the M code. L2C has been, and then if you take this slide, everything to the right of when that new capability comes along, the date on the top there, is every satellite after that event has that capability. So the legacy ones, but also the new capabilities coming along. So the next major modernization development was the introduction of the L5 signal from 2010 onwards, with the launch of the first 2F spacecraft. And then with Block 3, the 6 of those that are there now, we've got the new L1C signal. So sits alongside the original legacy L1CA code there, which is still there, works alongside that. And this is a signal that's compatible with Galileo to give a global signal for the first time across two systems. But if you look at those, and let's assume we get to the stage of talking about we need 24 satellites to declare a system, a capability operational, then we've only recently reached, earlier this year, 24 satellites with the L2C signal on 24 of those satellites. So we're at the stage now in terms of the spacecraft, where with 24 operational spacecraft broadcasting L2C, you would think the system would be declared operational. At this moment, it's not, and I'll come on to why that reason is in the next stage. L5 was really seen as the critical development in terms of civils. It moves us out of the L2, where the military signal's there. It's a part of the radio spectrum where there are only civil signals, the L5 signal, and the bandwidth is much greater there and allows much greater capabilities. So to some extent, the future of civil signals is seen as the L1C and the L5, with the L5 offering great advantages. However, if you think about, I know you remember the numbers that were on the previous slide back there, we've got 6 of the GPS-3 spacecraft broadcasting L5 and now 11 of the 2Fs. So quickly doing the maths, we've got 17 satellites transmitting 2F. And this is a system that was first introduced now 13 years ago, and we are still waiting to have enough satellites to get L5 maybe seen as the major stepping forward in terms of GPS operational. And if you again go back to my previous slide, we talked on there, only 4 satellites are actually scheduled for launch over the next 2 to 3 years. So that's only going to get us up to 21 satellites. So it's still going to be many years until the L5 signal is able to be declared operational. So what is holding up these? Well, I've said the success of the spacecraft themselves is one of the factors. Another factor, though, is down the bottom here is if you like, the ground segment and the changes in the ground segment that support the spacecraft. And the major problem here is this next generation control segment, or OCX. This has been widely reported, massively over budget, massively behind schedule, got to various critical stages where the program was almost cancelled, which would have a significant impact on the future of GPS. It's now operational at the first stages of that. At least it means that you can support the launch of the GPS-3 spacecrafts, what's called version 0. But the first operational versions are not going to be released, it's not expected now, until about a year's time, probably December 2024. Without that new operational control segment, they are not able to fully support the L2C and the L5 and the L1C signals, which is why, although there are now 24 satellites, as I say, transmitting the L2C, it's not been declared operational because they don't have the ground support to support those signals and that new operational service. So you can see a series of factors perhaps delaying GPS modernization. I won't say very much about GLONASS at all, mainly because a lot of there's very little reliable information now about GLONASS because of changing political situations, the war in Ukraine over the last few years. It's been very difficult to get up-to-date and meaningful information about GLONASS. In terms of the status of the spacecraft, we can find that, but in terms of what the actual plans are and developments taking place, it's very difficult to get any up-to-date information. There are no longer speakers coming to conferences. Publications aren't appearing on the websites. So this is a rather historical slide now, showing this developmental process, again, through the legacy satellites to the left, the original GLONASS ones, through GLONASS M. Every satellite is at least GLONASS M in the operational constellation. And then they've been moving towards the GLONASS K spacecraft over the last few years. What we have seen are new signals. And just to explain this slide very quickly for a few moments, the main difference between GLONASS and GPS for many years has been the way they broadcast the actual signals themselves. GPS uses a system called Code Division Multiple Access, or CDMA. GLONASS uses Frequency Division Multiple Access, so each satellite transmitting on a different frequency. So the slide you can see here, the legacy signals, if you like, are the FDMA ones on L1 and L2, and then new signals coming along with the CDMA type of modulation coming in the future and broadcast. And as we move forward, the O's and the S here are open signals and secure signals. So ones like the GPS and similar characteristics. Sorry, I was trying to obscure the sun from my eyes, and it's now coming around the corner. So excuse the white band that's coming down my face. And as you can see, as we move forward, we've got the legacy signals continuing, but then newer signals in terms of CDMA signals on the L1, their L1 and L2 frequencies, and their new L3 frequency, which is similar to the GPS L5 frequency, or adjacent to it. Galileo, again, this is a legacy slide I've got now, and this was the revised deployment plan published in around about 2020, 2021, and it's correct up until that orange red line I've drawn down the slide at the end of 2021. So the last launch that took place was launch 11 at the end of 2021, so 2 years ago now, and there hasn't been a launch throughout the whole of 22 or 23. And you can see the dependence there on terms of launch 12 and 13 in critically, and then sustaining launches beyond that once per year haven't taken place. And again, this is a result of the use of the Soyuz launcher for those capabilities. And that, again, because of the political situation, the war in Ukraine, those staff, Russian staff supporting those launches of the Soyuz spacecraft have been withdrawn from French Guiana. And so those launches are not taking place. So 12 and 13 are critical in terms of reaching the satellite numbers to get the full operational service for Galileo. The satellites are there, they're sat in storage, and it's not at the moment seen that Soyuz launching is realistic. The planned launch platform was Ariane 6-2, and that is the Ariane 6 spacecraft with the 2 boosters at the bottom, as in the figure on the bottom right-hand side there. There is an Ariane 6-4 as well, which has, not surprisingly, 4 boosters with a heavier launch capability. That as itself has suffered many, many delays, and there is now the first experimental launch is not expected until perhaps the second quarter of 2024. And of course, that needs to be successful before any Galileo satellites can actually be launched. Therefore, other alternatives have been investigated in terms of USA and Japan. And some of you may have seen a recent announcement that the European did form now a contract with SpaceX to use the Falcon 9 launcher to get these critical spacecraft again. So this is a different factor, a political factor, which has affected the Galileo simply because they don't have a launch capability to actually get the spacecraft actually up there. Itself, the system is continuing to operate very well. One thing that has happened, though, in Galileo is the introduction of new capabilities. And because of a slightly more flexible approach in terms of the spacecraft, some of the signals that were originally intended for different purposes, in particular the public regulators, the commercial services within Galileo, as that business model evolved over a number of years, those signals are now being reused for other purposes. And 2 critical parts of that you'll be perhaps familiar with over recent years now is the authentication service, which is OSNMA. So this is a wrapper, if you look, that's put around the data aspects of the signals, which means you've got more confidence that the signals are arriving you directly from the satellites and are not being interfered with. This has been tested for some time. As far as I know, it's still not fully operational, but there are advanced testing of that, and it should be operational very soon. That's the open signal, and there is postulated a commercial version of that as well, where even greater encryption of the signals, rather like the public regulator service, will be made available for commercial use. And a service that is operational and has been now operational since the start of the year is the high accuracy service. So extra information to allow precise point positioning directly from the spacecraft. So using the E6B signal to actually relay that data if you have receivers that receive the E6, or using just an internet link into your receiver to get that information. And this is more precise orbits and more precise clock models that would allow you, with modeling of the atmospheric effects in one way or another, to get down to that decimeter or centimeter decimeter level in real time. Critical factor with any precise point positioning is what we call the convergence time. So how long does it take the solution to converge on an acceptable level of solution, whether that's 5 centimeters or whatever it is specified. Critical within the PPP is that, and therefore there are different levels of service in terms of a global service and a regional service, which will have different rates of conversions. So the service definition document shown on the screen there, it was published at the start of this year, and the services now are to be declared operational. This slide is slightly out of date, actually. It is actually operational. So those 2 levels of service, as I've said, this is just a copy from one of the actual official slides for the Galileo program, giving some of the technical information. I won't go through in great detail, but you can see the level that we're talking about there in terms of the service levels of the order of decimeters in terms of horizontal or vertical accuracies. The difference between the European and the global being primarily the convergence time, if you see about the 5th line down there on the table. Galileo itself is also undergoing modernization. For a number of years now, this has been studied into what as the Galileo 2nd generation, originally called G2G, but in many cases now it's simply abbreviated to G2 in terms of the program. First of all, 2 different manufacturers of the spacecraft, from Astrium Defense Systems, based in Germany for one block of those, and from Thales Alenia, sorry, Spatial, based in Italy. Contracts awarded for both those contractors to build the spacecraft to give a diversity in spacecraft design and manufacture now, rather than relying on a single contractor. So contracts for 6 satellites, initial 6, have been awarded to those 2 different contractors to build the spacecraft. And it was announced yesterday, some of you probably saw some of the announcements, that the first 2 of those satellites from Thales Alenia are now at ESTEC in the Netherlands, undergoing the testing of the spacecraft. So the spacecraft have been built and they're now being tested at ESTEC. And the platform to deploy 2 satellites at once has now been, the new platform to that has been tested as well. Alongside those generations of new spacecraft, there's been many contracts to look at new generations of satellite clocks, obviously critical to satellite navigation systems, and also in terms of future developments of the ground segment and the test beds. So all that work is taking place and is contracted throughout Europe now. And of course, from many of our point of view in the UK here, we are excluded from all those aspects in terms of developments now. So as I say, I thought I would finish off by just talking about some of the more general governmental actions, national actions working towards PNT, positioning, navigation and timing, and look at 2 parts, 2 aspects of that. First of all, looking at the output and recommendations from the National Space-Based Positioning, Navigation, Timing Advisory Board of the US government. This is a presidential advisory board, so we are there, I'll explain that in a moment, to advise the executive committee of the US government, which operate GPS as a multi-agency approach led by defense and transportation in the US. So the advisory board sits there as a presidential level advisory board with primarily US representatives from industry, from research organizations, from universities, to actually provide that insight and advice to the US government representatives. And there are a number of external agencies, so the Resilient Navigation Forum, for example, the GPS industry representatives, and 3 international representatives, myself, somebody from Australia, Matt Higgins, and Renato Filia, who many of you know from Croatia. So we are the 3 international representatives to that board, and the board meets every 6 months, and we will reconvene next week in Houston in Texas. But what I want to show are the recommendations from the meeting a year ago, the 27th meeting. We met in May, but the formal output from that in terms of the changes of the recommendations have yet to be published, and I'll explain why in a few moments' time. So this is the actual recommendation that came from November 22. Now, it's a bit wordy, I'm afraid, the next few slides. This is something you should never do on PowerPoint presentation slides, as I used to teach my students. But I just done it because I've stated verbatim what the recommendations are, because these are official recommendations that went to the government, US government, and I didn't want to paraphrase them. I thought it'd be easier to actually state them directly. So here are the recommendations. There's a few slides of these, and you can see if we just pick out some key words and I won't read them, of course, but you can see here we're talking about developing monitoring and disruptions and public warning in terms of interruptions to the signals, to expressing the effect of any outage, which similar studies have taken place elsewhere, to create a structure to provide public warnings if there are significant interruptions. And again, many of you will be aware of some of the interruptions that have taken place in the US in terms of major incidents at airports in the US over the last 12 months or so. Developing this interference detection and reporting system, some things that have been promoted for many years now, and there are services available in other countries potentially that could be, but introduction of some sort of system in the US. Clearly, these recommendations are very much US centric. Looking at the governance part of it, if you like, and how that comes through in terms of, again, representing that in terms of cybersecurity threats. Greater clarity from the US government. You can see one thing here, very similar to what I was just talking about with Galileo, is the proposed introduction of a GPS high accuracy and robustness service. Because of the constraints I mentioned a little earlier about the US GPS spacecraft, this cannot be provided on a signal in the same sort of way that the Galileo high accuracy service is broadcast on that E6B signal. Because there isn't the capability in the spacecraft to allow that modification in terms of the broadcasting. And so what we're talking about here is just an internet level of access there. It's thought that most of the ground infrastructure is there in place in terms of the existing global differential GPS networks operated by the Jet Propulsion Laboratory. That could provide the orbits and the clocks. It's a matter of making a service available through the internet for that. And as you can see, something close to my own heart at the bottom there, something again we've been trying to discuss extensively with the UK government, is the investment in training. This came out primarily, and that's why the word geodesy is there in the final line, because of a report from the National Geodetic Survey in the United States acknowledging the critical level of the training or lack of training of US experts in geodesy. Obviously, geodesy is one component that underpins satellite navigation systems and the uses of them. And we've broadened this now in terms of the meeting we had last year, in terms of just representing the PNT shortage itself, in terms of expertise. So in terms of signals, in terms of spacecraft, in terms of all the engineering, and in terms of the applications, so not just geodesy. So lobbying for greater funding and investment into the future of education and training at all levels. So this is not just saying we need more PhDs, it's saying that we need more at all levels of introductions into the industry to support it. This is not just a factor in the US, and you'll see this is another critical factor when we start talking about the UK or elsewhere as well. I said that these recommendations were reconsidered back in May this year, which was the last time that the advisory board met, and that was to tidy up some of the wording and also to try and make them more deliverable. Because although these recommendations were made, there has been limited response to them. And that was because some of the wording was perhaps not tight enough. So, for example, this recommendation here about funding, it didn't say who should increase the funding, it just said the US government. It didn't say which agencies, it didn't say how it should do that, it didn't say what the impact would be. And so a lot of the work since these initial recommendations has been tightening up that work so we can make very clear and distinct recommendations with an evidence base as to what should happen and what the impact of that would be. If we carry on, again, I won't go through these all in great detail, but we're talking again about the again, the interruptions to signals. We're talking about the celebration in terms of the second recommendation down in terms of what I talked about earlier on this year, in terms of the 50th anniversary. The protections of the radio spectrum, as I'm sure a number of you will be aware, there has been an issue ongoing for many years now in terms of introduction, potential interference from terrestrial-based transmissions in an adjacent band to the GPS signals, and how some parts of the US government approved those signal broadcasts, whereas many parts were talking about worried about the impact that would have on GPS services. So reviewing the use of the radio spectrum. If we move into the UK, then, and again, it's a long history now in terms of trying to raise the awareness of the criticality of the reliance we now have on not just satellite navigation systems, but positioning and navigation timing in general. And I said the criticality of that reliance, but also the impact of the removal of any of those services, and subsequently perhaps the lack of systems that could be there to provide complementary signals if there is any introduction and any interference or removal of service from the core systems that we're all using, such as GPS and Galileo and the other systems. So this goes back for a number of years now, and I've just highlighted a number of reports here, which key stepping stones along the way. So what was called the Blackett Review back in 2018, a number of us were members of that review committee that tried to look at the impact on a range of different sectors and try to explain that critical dependence there was, not just in areas of critical national infrastructure, but across the board, and express that in terms of a series of recommendations which were made to the UK government through the Cabinet Office. I've already mentioned the space-based PNT program. This was a study that was taking place within the UK Space Agency, started in 2020 and reported. That report did not come out until very recently, and because it was then, I guess, they're overtaken by other events which were considered important to consider the issue as a whole rather than one small aspect of it. And then various other reports, a strategy document was produced, or a potential draft strategy was written up to 2021, again led by the UK Space Agency and other organisations. Again, that was submitted to Cabinet Office and proposed for the first time the structure that there should be some sort of national cross-governmental office to manage the PNT within the UK, and perhaps some structures about how that might operate. But then with both those reports, they were overtaken by events, and nothing actually really happened in terms of the outcomes of those, although they were very important documents to have, if you like, in the Cabinet, waiting for other developments to take place. And then more recently, the UK Integrated Review and the National Space Strategy again highlighted government documents highlighting this criticality of this reliance and the lack of resilience in the current systems we have in terms of PNT provision. So that again came to a focus last year, towards the end of last year in October. Two critical documents were published from two House of Commons select committees, the Science and Technology Committee and Defence Committee. These documents are available if anybody wants to see these documents. And they really focused in on, again, this issue, recognising the issue of the lack of resilience we have in terms of PNT and the critical dependence we have on a limited number of signals. And that really led to the start of the current work, which has now culminated in the publication of the policy framework we had about a month ago now. So that led to the establishment of the cross-government, it was called the PNT National Office demonstrator project, which brought together a team for the first time to try and bring together, to drawing on all this work that had taken place since 2018 and the Blackett Review, and developing a series of policy options which would, I guess it says there, mitigate against the risks of the loss of PNT. So pulling it all together, looking at key components as you would probably expect there in terms of what was there at the moment, what are the risks and threats, what is the issues with resilience and mitigation, what are the user requirements across different sectors of not only critical national infrastructure, but more generally, what are potential solutions, how does this work both nationally and internationally, and finally that box item 7 there, what could be done relatively quickly to address some of these matters. Again, various parts of governance in the right-hand side there at the bottom there in terms of the project board, community of practice, bringing in different government and external practitioners, and then once an independent expert group, which I and a number of colleagues who are probably sitting on this were members representative towards, to provide expert advice and guidance against those issues to the left there, those key components. So that all took place and reported earlier this year in terms of the recommendations. And then about a month ago, we had the publication of the framework. And again, without going into great detail, and because of the same issue I said previously, I've just stated these almost verbatim from the press releases that came out from the new office. Well, first of all, establish this PNT office, this national PNT office. It sits within Department of Science, Innovation, Technology. There's a growing staff there. So we've got leadership now, and we have growing numbers of staff which are being recruited to that team. So it's going to be their job to drive this PNT policy coordination and moving it further forward in terms of delivery. Creating the crisis plan, recognizing those threats that I was talking about a little bit earlier, and what responses made those, and what are long-term and short-term mitigations. A key aspect is the use of PNT systems in terms of GNSS in particular, in terms of timing provision, and many of the aspects of critical national infrastructure. The reliance is primarily on timing rather than positioning. And so establishing the National Timing Centre, establishing the high-quality UK-based UTC. From a military point of view, again, extending that with a parallel development in terms of the Ministry of Defence time. I won't say any more about that. And then looking at what systems could provide complementary positioning services or timing services to address the requirements that are recognised, and ELARAN being one of those. So building on the current single transmission we have from Cumbria, which has been operating for a number of years, developing into a system which will provide both timing and positioning and navigation. The working in terms of the receivers, in terms of improving the infrastructure through receivers, therefore improve clocks in terms of receivers that are working across a variety of signals, again, across a range of CNI sectors. I talked earlier on at the start there about the possibility of a UK-based space-based augmentation system. So taking that further and beyond what the capability you might have for just aviation requirements, which is primarily to do with the integrity of the signals, whether you can trust the signals, and looking also towards a precise point positioning type approach where you're talking about higher accuracy as well. So providing a national service to provide that augmentation of the basic GNSS signals in terms of integrity and in terms of accuracy for applications such as autonomous vehicles and precision users. Again, rather like the US recommendations here, recognizing that we do have a skills shortage within the PNT sector. So not just at the doctoral training level, but at all levels, coming up from apprenticeships and other schemes to increase the knowledge and awareness of PNT, but then through the education and training to have that ground base of sovereign skills to develop PNT through the future. Developing the further policy and recognizing the impact of this on growth, and so through standards and testing to drive the future innovation, and looking to the future. I've talked about the considerations there were for a UK-based space-based system itself. What other systems are there in terms of quantum navigators and other sovereign capability that could be developed in the UK as the next generation? So that's a quick summary, just to give you some idea about what has been happening within the UK in particular over the last couple of months. As you can see the date at the bottom here, all this was published just on the 18th of October, so just over a month ago. The RAN itself, we had an event on the 7th of November down in London at the Royal Society, where we considered many of these options and discussed some of the implications of that. The RIN itself is not surprising, and with the title of this group is that we have set up the UK PNT Advisory Group to try and bring together within the RIN as an independent learned society, an independent body, so not lobbying for one particular technical solution or one particular industry, but trying to represent as a knowledge base to provide help and advice and guidance to the UK government and other agencies as well. So this has been established for some time now under the leadership of Andy Proctor, and a number of us are working within that. And so I just want to show one slide. It's quite busy now because we are doing quite a lot, but this is the current timeline in terms of what we've been looking at. So looking at the economic impact paper that was created a number of years ago and updated recently in the government publications, how can that work be developed further? Looking at particular aspects such as the low Earth orbit satellites, which have been discussed. So we held an event at that in March of this year, and very good discussion as moving forward. Looking at the fact of the probably national test beds and what should be the cases. Looking at technologies like the quantum technology and PNT, and potentially an event coming out in early next year. The same with artificial intelligence. We had the first discussion group just a couple of weeks ago, or within the last couple of weeks. That's expected to move forward. And various other things in terms of white papers and other guidance support that we're hoping to take forward. As you can see, down the bottom there, a defence event that was held again in early this year, and moving forward to future events where we'll be considering defence aspects of PNT. So a very active group. If any of you want to be more involved in those, then please get in touch with Claire or with Andy Proctor directly, and we welcome information and support to help that work. So I think I'll leave it there for today. My contact details are there if you've got any questions, but I'll hand it back over to Claire now and invite any questions from anybody out there, which I'll try and answer.